Hello and welcome to this lecture where we'll go into Docker and we'll go into a Docker container. We'll start with Dockerizing an app, and then we'll jump into the Docker container to investigate what is inside of the Docker container so that you understand inside, under the hood, what is there. So without further ado, I will move into Visual Studio Code. I'm inside of Visual Studio Code. I'll open a new terminal and let's set up some stuffs. This will be similar to the lecture before in the setup, but I will code along here and explain more in detail. Let's create some files. Touch app.py. I will create a Docker file. I will create the requirements.txt, and let's do that. I won't create the requirements directly. I will generate it from my virtual environment. Okay, talking about virtual environment, let's create that. And then I will activate my virtual environment. Source when bin activate. I will now have activated my virtual environment. Let's install something. Pip install. I will create that one first. I will start with pandas. Yeah, I could pip install matplotlib as well. So now I install pandas and matplotlib. Pip freeze. And I will freeze the requirements and save it into requirements.txt. So if I cat requirements.txt, you can see these are the packages that are inside. You can see it's these packages here. Okay, cool. So now I've installed to my virtual environment. Let's create my app. I will use the same code as in the last lecture. So import pandas as pd, and then import sys, and print sys.version, and also I'll create data. This one I'll copy directly as I won't type it out, and you don't want to see me type it out. So here basically it's in Swedish, so namn is name. Actually I can change it to name, age, city, and salary in SEK, so Swedish crowns. Okay, and then I'll create a data frame. So df equals pd.dataframe of data. And basically I just printed my data frame. So print df. So if I run this one locally, let's see what happens. No module name pandas. Yeah, that is because I haven't chosen my virtual environment here. So I can choose my virtual environment, enter interpreter path. Or actually, I will increase this a little bit like this. And now if I run this on again, you should see that it works. Yeah, it works. So you can see here's the data frame written out, and also here is the version 3.11.8. Let me make it a little bit clearer here. So print \n/n. I will have f string. Okay, let's run this again. F string, need to end the string like this. And let's run this again. Yes, and you can see here, sys.version equals 3.11.8. Okay, cool. Now we have 3.11.8. I will show you that it will be different when we use the Docker file. So I'll change it a little bit. In the Docker file, let's do like this, from Python. Actually, you can choose which Python you want. Let's go into the browser and I will show you. So here in the browser, we can go into Docker Hub Python images. So I will go in here. And you can see here's the Python official images, and you can see which type of images there are. So basically here, you can see there's a lot of different versions, right? So you can choose a specific version. If you want it to be simpler, you can choose the slim version, etc. You can read more about what each version is. Basically, this is, so it's in the Docker Hub, which you find the image that you use for when you're specifying the from statement in the Docker file. it will pick an image that exists in the Docker Hub, which someone else have published, right? So this one is published. So this one has different configurations already set in each of these. So let's just pick one. So I'll pick 3.13, for example. So let's do like this, Python 3.13. 3.13. So from, and then I will do work dir. So the work directory is where I want to, where is the entry point in my Docker. So inside of my Docker container, I will choose. So this means that in the root directory, I have a folder named app, and inside of this one, I will place my files. So I'll do copy. Dot means that I copy all the files from this folder here into the, actually I will do like this. I will create another folder here. I'll call it app here as well. And then I will place all this file into the, I'll say this one, and I will place all these files into app. When doing this, I don't get my .venv sent into the Docker container, which is what I want. Okay, we have copy dot. So I copy everything from within the app because there's where the Docker file lives. And it will send into the app folder of the container, right? And then I will do run pip install -r requirements. So basically requirements.txt. And this is basically what you're doing when you're installing based on an existing requirements, right? So run is just a command to run a bash command inside of the container when I'm building it. So let's do the command. What command do I want? Well, I want to have Python and I want to have app.py so that I will run this app.py inside of my container whenever I'm spinning up the container. So let's continue now. So I will do cd app. So I'm inside of this app, and here I will build my image. So docker build and build dot. Then I will want to tag it. So -t. What do I want to tag it? I will want to give it a name. I can give it like pandas Python demo image, for example. And I have to have the dot in order to get the Docker file in this folder. So I run this one. And now it will build the image. One thing to note is that while this is running, I can say that it's important that you have your Docker engine or your Docker desktop started. Otherwise, your Docker commands won't work. You can see that it has created several layers and exported the layers here. You can see that we have, for example, work dir /app, and we have copied and run pip install. So it runs several things. Here, the first one is from the docker.i. This is a hash code. It chooses from the Docker Hub some hash code, which means it finds the image to download and it extracts it to install. Cool. I can clean my terminal now and I will do Docker. So I will list everything in my image. And inside here, you can see that, oh, Python demo image. This one I just created. So cool. So now, based on this one, I will just do Docker run --name. So I can give my container a name. And the name I will choose is, for example, Python container. And then I will need to choose the image that I will run from. And this is the image that I've created. You can see the image as a snapshot. It's a snapshot of the current situation. The current situation contains these, right? So I will choose my snapshot. I'll choose my image, Python demo image. Cool. When I'm spinning up the container, it will run this command, Python app.py. Since I have in my Python script. I print this out, and you can see the print. You can see the version 3.13.1. And you can check my system version, Python -- version 3.11.8. So you can see it's an isolated environment. My Docker container is isolated from my host system. I have another version of Python in the isolated environment. So cool. Okay, let's move on to find out a little bit about our Docker container. Look at the Docker PS. This will list all the containers, or you can do Docker container ls. You can see there's nothing here. Why is that? Well, because our container closed. After it says run, it's done. It's closing down. However, if you're opening up a port and, for example, you're running a web server, then it's continue to run until you stop the container yourself. So nothing is telling it to continue to run. I cannot see my container. However, if I do Docker ps-a, then I will list all the containers, even the closed ones. You can see here, here's the container ID, Python demo image. It was this image. The command that has run, Python app.py, was created about a minute ago. It has exited about a minute ago. The name, it's Python_container. So it has exited. However, I can interactively run this one. So I can do Docker exec-it Python container /bin/bash. Error response from it's not running. Okay, it's not running. Right. Docker exec yeah, because it's not running, I cannot open it interactively. However, I can do like this: Docker run it, not Python container, but demo image. So this one, I run the container. I spin up a container using the run command, right? Because when I used run before, I spin up the container. But now I have the flag -it, which means interactive. So I run this, I spin up this container interactively. And when I spin it up, I tell it which command I want to run. I want to run /bin/bash. So I'm running a bash command line interface inside of this container now. So let's do like this. pwd. I'm inside of app. I will investigate a little bit what is inside of this container. ls, we can see the files. Let me zoom in a little bit in my terminal so that you can see it clearly. Inside of my Docker container, you can see these are the files that I sent in. If I do cat app.py, you can see this was the code that I sent in. I will clear this. Cat requirements.txt, and these are the requirements. Are they installed? Let's check out pip release. And we can see, yes, they are definitely installed. They are definitely installed. So can I run a Python shell here? Yes, I can. And it's 3.13, right? Can I import matplotlib? No problems, I could do that. Import pandas. Yes. Import sklearn, scikit-learn. No, because I didn't install it. Makes sense. Okay, great. So I can quit from here. Oh, the terminal looks really nice in the new Python. Okay, let's do like this. So ls, I'm here. cd, app-step. I'm in the root. pwd, you see /. This means I'm in the root of my container. What exists in my container? ls. Ooh, it's you can see that there exist a lot of things now. There is this app, which we created, right? But there's also a lot of other things. So let's try the bin. cd bin ls. There's a lot of things inside of bin. These are things that you can run. For example, you have Python 3. Can I do ls grep to find things that I want? I want to find bash. You can see here we have bash inside. That's why I could run, before when I ran interactively, I did /bin/bash. Because bash is the command line tool. This is the software that I was running before. So cd, go up. But can I check a little bit more? Who am I? Root. Yes, this is my user. It's called the root. So which Python? I can check where it is installed. It's installed in user local bin Python. ls, do I see a user? Yes, I see a user. So cd user, ls bin, cd bin, ls. A lot of things. Can I see if I have grep Python? Yes, Python 3 and Python 3.11. It's interesting. So going back, cd dot dot ls cd dot dot. Let's see if I can find. I want to check which operating system I'm in. Can I do which OS? No, I cannot do like this. I'll check the date. Sunday, January 19 UTC. For me, I'm in Swedish time, so 1949 I am. If I do date again, 1849. Okay, great. Let me see how to check the operative system. Let me see. uname-s. Okay, I'm in Linux. Cool. So then I know I'm in Linux. Okay, let's try matplotlib a little bit. What happens if I'm plotting something? First, let me change this file a little bit. So if I add things, for example, I do df.plot. So df.plot, then I can choose what should be my x. X should, or actually no, I want to plot. I want to do like this. Import matplotlib.pyplot as plt. df.plot plt.plot or fig, x equals to plt.subplots 1, and then I will do x.plot. Let's do bar. x.bar. I will have x equals to data of names, name, height equals to not data, df, or I could use data, but I do use df, df of age. Cool. Then I have my x, and then I will do fig.save fig. I will save it in the same folder. So let's do like this. From pathlib import path. Okay, so this I will choose which name to pick. Let's say ages.png, like this. Basically, this will output a PNG. So let's continue like this. cd app ls. I will do cat. I will do python of app.py. And you can see nothing changes. So if I do cat app.py, and you can see these import things is not there. All the edit, none of the edits are there. That is because we just copied. Note that we did a snapshot here in the Docker file. We copied everything in dot into the container. We copied everything into the container when we built the image. So let's do like this. I will do Control D to jump out from my container, and I will do docker build -t. Let's see what this is called. Python demo image dot. Then I will run this again. Okay, so it installs the requirements as before. This will be faster because we already have it cached. Now let's look like this. The Docker image ls, you can see that we have the same image. It seems to be the same image, but it's actually updated because I haven't done several versions of it. If I just did the command as before, like this, then it will overwrite the old one. So let's continue to check now. So if I do docker run -it, I don't care about the container name now. So I'll just do docker run -it python demo image, and then I will do /bin/bash. Okay, so I'm inside of my Docker. So if I do cat app.py, you can see, yes, this is the updated version. Cool. Let's run this one. Python app.py. Okay, it seems to be nothing happened, right? However, if I do ls, we can see there's ages.png. This is unfortunate that I cannot open this ages.png, right? And also, it doesn't come back here to my by my host system. So it exists inside of my container. It exists inside of my container, but I cannot access it. So if I do docker, let's see, and I do cat ages.png, yes, you can see there's a lot of information here inside of this PNG file, which I cannot read using cat, obviously, but it exists there. But now I will exit from my Docker container, and you can see it does not exist there. So let's spin up a Docker container again. So I will spin up a new one. And I'm inside of app, I will do ls. You can see, unfortunately, it's not there. So as in the theory, you can see this is the container layer, which is read and write. However, it only lives during the lifetime of the container. After the lifetime, these files does not exist anymore. So let's exit from this. So I will save bind mount for the next video, where I will go into Docker Compose, where we can spin up multiple containers. I will simplify it and just spin up one container for the next video. In the next video, we'll come into Kafka. I will spin up several containers using Docker Compose. I will save bind mount and volumes for Docker Compose. Thank you for watching this video. See you. Bye.